I'm Anil Kumar. Welcome to my series on trigonometry. In this video, we have taken challenge examination style questions for your practice. Now, these are based on half angle formula and we'll be working on tangent ratios. In case you want to learn from me, you can always send an email on the address given here. Please check our website for the latest updates. We have two related questions here. Question number one is, you are given that t is equals to tan x by 2 for x being between minus 360 degrees to 360 degrees. And you need to show that cos of x is equal to 1 minus t square over 1 plus t square, and sine of x is equals to 2t over 1 plus t square. Question number 2 here is, use t equals to tan theta by 2 to solve 3 cos theta plus 2 sine theta equals to 3 for theta being between minus 360 degrees to 360 degrees. You can pause the video at this stage, answer the question, and then look into my suggestions. Now here are some hints for you to solve this type of question. Well, hint number 1. You are given that t is equals to sine x by 2. Make a triangle, and this triangle will help you to solve the question. You might also need some formulae, so I've given you double angle formula. Cos 2x is 2 cos square x minus 1, and cos 2x can also be written as 1 minus 2 sine square x. You might use these formulas also. So with that in mind, I think you are fully equipped to answer these questions, make an attempt, and then look into my suggestions. So let's begin with the solution of the very first question, which is, we are given that t is equals to tan x by 2, right? So basically, we'll make a triangle. If x by 2 is the angle, we know what is tan theta, right? So tangent ratio is in general equals to opposite side over adjacent, correct? So since we are given that this is equals to t, so we are writing opposite side as t and adjacent as 1. So that is how you get your triangle. Once you know that these two sides of a right triangle, in that case, hypotenuse is sum of squares, square root. So we get t square plus 1 square root as the hypotenuse. Correct. Now, let's look into the double angle formula. Cos 2x is 2 cos square x minus 1, and so you can replace 2x with half of it. So you get cos x as 2 cos square x by 2 minus 1. So you normally get half angle formulas from these double angle formulas, right? Now if I rearrange this with the values given to me, that is, that from this particular triangle, as you can see here, from this particular triangle, I could write what is my cos x by 2, right? Cos x by 2 is 1 over t square plus 1, and sin x by 2 is t, the opposite side, over the hypotenuse, square root t square plus 1. So once I know these two values, then for cos square x by 2, I can substitute my value, which is 1 over square root t square plus 1. So I substitute that value here. You get the idea. So 2 times cos square x by 2. So we have done the value of cos x by 2 and squared it. You get the idea. So we get cos x as 2 times 1 over square root of t square plus 1 whole square minus 1. Now, just square this, get rid of this square root, simplify taking the common denominator, and you get your result, which is cos x is equals to 1 minus t square over 1 plus t square. So I hope this is absolutely correct and clear, right? Okay, now part B is to prove that sine x is 2t over 1 plus t square. Well, you can again use the double angle formula and follow these steps to get the answer. Or what you could do is make another triangle with what we have just shown, which is cos x is 1 minus t square over 1 plus t square. And from there, you get the value of sine x, right? So you could do that. Right? You could also use the identity cos square x plus sine square x is equal to 1. So there are many ways to do it. So what we have adopted here in our solution is another triangle. I want to focus on the strategy of making triangles to solve these questions. Now, this is a very important strategy which we are going to use many times, especially for solving such complicated questions based on trigonometric ratios. Okay, so we'll begin now with what we have just shown, which is cos x is 1 minus t square over 1 plus t square. So I can make a triangle where the adjacent side is 1 minus t square and the hypotenuse is 1 plus t square. Now you know this is a right angle triangle, and therefore the opposite side should be equal to what? Opposite side will be square root of the difference between the hypotenuse square and the base adjacent square. So we applied the Pythagorean theorem and this formula to find the length of opposite side. Now this length of opposite side will be equal to square root of t square plus 1 whole square minus 1 minus t square whole square. Expand and simplify. So when you expand the terms with t to the power of 4 and the constant cancel away, and the minus 2t square and plus t2 square form to become 4t square square root. That gives you 2t, and therefore the opposite side is 2t. Once you get that, then from this triangle sine x is equals to 2t over 1 plus t square, and that is how you prove part B of this particular question. So I hope these steps are absolutely clear, simple to understand, perfect. Now let's take up the trigonometric equation, which was our question number 2. Let us see how to solve this particular equation. Now in this equation we are given again t is tan theta by 2. So what we could do here is that the values of cos theta and sine theta, which we derived in question number 1, can be substituted and you get an equation in t itself. Then it becomes a quadratic equation in t which could be solved and we can get the result. So I hope you got the idea. From here you can actually pause the video, try it out, and then check with my solution. That'd be great. Perfect. So let's move forward. So we are given this equation 3 cos theta plus 2 sin theta equals to 3. And we just derived that cos theta is 1 minus t square over 1 plus t square. We'll substitute that. Sin theta is 2t over 1 plus t square. We'll substitute that. And now what? Just take common denominator, multiply that on both the sides. So you get a quadratic equation which will look like 3 times 1 minus t square plus 4 times t, right, equals to 3 times 1 plus t square. Bring all the terms to one side, 0 on the other, simplify. We get 6t square minus 4t equals to 0. Take 2t common, so we get 3t minus 2 equals to 0. Now, for this equation to be true, t equals to 0 or t equals to 2 by 3, correct? So that is how we get these two values of t. Now, what is t after all? Well, t is given to us as theta by 2. So, theta by 2 is equals to 0 or theta by 2 is equals to 2 by 3, correct? So these are the two equations to solve. So we wrote instead of t, theta by 2, tan theta by 2 equals to 0 or tan theta by 2 equals to 2 over 3. Now, theta by 2 should be in the domain of half of 360s, right? Plus minus. So we are looking into this particular domain now, minus 182 plus 80 degrees for theta by 2. So now, if tan theta by 2 equals to 0, then the value of theta by 2 is minus 180, 0 and 180 degrees, correct? So you get the value of theta as times 2, minus 360 is 0 and 360. So that is a part of our solution. The other part of the solution is solve for tan theta by 2 equals to 2 over 3. So theta by 2 is tan inverse of 2 over 3. Use your calculator, the inverse tangent ratio, and you'll find the angles are 33.7 degrees and minus 146.3 degrees within the given domain, right? So this is kind of important to understand. So at this stage, what are we doing? We're trying to solve for tan equals to 2 over 3. This is positive. So we are expecting the solution to be in quadrant 1 or in quadrant 3. Correct. So one solution will be this, which is from 0 to 180 degrees, and the other solution is this, correct? Which is from 0 to minus 180 degrees. Perfect. So that gives us the two values, which is 33.7 and minus 146.3. For tangent, the period is 180 degrees, and that helps you to get the answer. Perfect. Now multiply by 2 to get the value of theta, and so we get our answer. So theta is equals to 67.4 degrees or minus 29.6 degrees. So in this particular case, we get four answers, right? So we get four solutions. One, theta is equals to these three angles, which is minus 360 degrees, 0 degrees, 360 degrees, and these two angles. So we have five solutions in the given domain. Is that clear to you, right? So that is how we are going to solve this question. I hope the steps are absolutely clear. So with that, you understand. How do we solve such questions? Now, these two identities, which we showed here, writing cos and sine in terms of tangent, they are very important for many test related questions. I hope it makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.